All right, today we're going to be talking about Chapter 9, Lesson 2. This is called Theoretical and Experimental Probability. So when we are looking through talking about different kinds of probability, there are two different kinds. One is theoretical, and what that means is essentially what is expected. And then there's experimental probability. And what experimental probability is what's produced. So, for example, the experimental probability of flipping a heads or a tails is 1/2. The experimental probability is, depending on how many times we do it, it could be 1/2, it could be 2/3, it could be slightly more than 1/2, slightly less than 1/2. But we're going to go through and do some activity or do some examples to kind of show how we can see what the experimental probability is and how that compares to theoretical probability. So, first example, example 1, it says the graph shows the results of an experiment in which a number cube is rolled 50 times. Find the experimental probability of rolling a 4. So let's look at our chart here. Here's the number 4 that was rolled. And it says it was rolled 9 times. So the probability again, that is equal to successes divided by trials or outcomes. So we had 9 successes where we rolled a 4. There were 50 times that we tried it, so this would be 50. Now, if we go ahead and find the decimal approximation of 9 divided by 50, we would see that this is 0.18, or 18%. Now, in example 2, it says compare this experimental probability in example 1 to the theoretical probability of selecting a 4. Now, on a number cube, there are 6 total sides, so there are 6 different outcomes. Rolling a 4 is one of them. Now, if we make this into a decimal, 1/6 is going to be 0.16 repeating, or about 0.17. Which would be 17%. This is theoretical. This is what we should have gotten. However, what we did get was 18%. And this is experimental. So the way that we would say this is the two probabilities are close, with experimental being slightly higher than theoretical. Because 18% is greater than 17%. Now, if we look at another example, this is something that we can very easily do, but it says a coin is tossed 45 times and landed on heads 21 times. Find the experimental probability for heads. So, probability for heads, again, is successes divided by trials. And there are 21 times we landed on heads out of 45 total times. Now, 21 and 45 both have a common factor of 3, which means that this is really going to be 7 out of 15, which gets me 0.47 or 47%. Theoretical probability tells us that there is 1 heads and 2 total outcomes, which would be 0.5 or 50%. So we would say in this case that theoretical probability was higher than experimental. In everyday language, what this means is we got less than we should have. We had 21 heads where we should have had probably 22 or 23. Somewhere in there, because 45, we want half of that. Half of 45 is 22.5. So we should have gotten another 22 or 23 of them, but we only got 21. So we got less than we should have. Now, the last thing that we can do with experimental probability is talk about predicting future events. So we can make predictions. By using probability. Probability. Essentially what we'd be doing here is saying, well, if the probability of getting this many numbers with this small group of people, we can extend that over a larger population, which is going to be a kind of an introduction to statistics, which we'll do later. Now, example 5, it says a survey of Mrs. Ramirez's students showed that 30 students will have pizza for lunch, 17 will have mac and cheese, 12 will have a hamburger, and 5 will have chicken. Suppose she surveys all 1,200 students in the school. How many students can she expect to choose hamburgers for lunch? So, what we're going to do is we're going to make a proportion. What we want to do is figure out how many students total Mrs. Ramirez has. So she had 30 that picked pizza, 17 that picked mac and cheese, 12 that picked a hamburger, and 5 that picked chicken. And if I go ahead and add these up, 30 and 17 is 47, plus 12 is 59, plus 5 is 64. So there are 64 students that she surveyed. So the probability, in this case experimental probability, was 12 hamburgers out of 64 people. And if I simplify this down, there's a common factor of 4 here. So this would be 3 out of 16. Couple different ways that we can do this. The most efficient way is 3 out of every 16 of her students said they wanted a hamburger. So how many would that be out of 1,200 students? Cross products. So this would be 16x. 3 times 1,200 is 3,600. And then I simply have to divide by 16 to both sides to figure out how many students can be expected to buy hamburgers, and that would be 225. All right, that is the end of lesson 2. If you have any questions, please let me know.